Right, guys. So I'm trying to show you guys the log rule derivation right now. We're just gonna, I'm just gonna try to quickly explain to you guys how certain rules that we saw earlier were derived, in fact, and how we can actually access those questions. One of the first things I would start with is the product property, which is if I have log base of, as an example, base x, y, that is the same as log base of x plus log base of y. Okay. Now, what the ones, oh, sorry, I'm just kind of freestyling this one. So bit of a, it's a bit of a struggle, for me to just recall what I'm saying. Let me just start that again because I think I just actually paused it when I was changing tabs. Let's start again. The product property is if you have log base of xy, then you have log base of x plus log base of y. Okay, how does that work? Let's start by setting an example. If I let m equal to log base of x, and then n equal to log base of y, then we start by thinking, okay, well, like the best way to write it would be to the power of m equals to x, and then b to the power of n equals to y. If I wanted to do b to the power of m times by b to the power of n, another way to look at that would be just b to the power of m plus n. Yes? Once I have that, this is the same as saying x times y equals to b to the power of m plus n. Okay? This, once we use BAP, this becomes log base of xy equals to m plus n. But what did we know about m and n just now? M is this guy, and n is this guy, which is log base of b plus x log b of y. That's how the product rule works. Product property, because product rule, we like to use it for differentiation mostly. Same thing for division, and everything else just kind of follows along. Okay. Now, once we have looked at this property of product, I guess, feature, things mostly start to make sense. And I'm gonna more of these questions would be ideal, okay? But I'm gonna try to go through this booklet really quickly, this page, and see how it goes. Okay. I'm gonna tell you when I would like you guys to pause the video and have a go at it yourselves, but let's see. When I look at a question like this and the question tells me to solve it, I think to myself, okay, what is this actually saying to me? This is telling me x to the power of 3.5 equals to 128. That's just changing the logarithmic form. I'm just trying to change it into the way it should be. If you realize if x to the power of 3.5 equals to 128, this is same as saying, sorry, I shouldn't use two lines because you might think it's equals. X equals to 128 to the power of 1 over 3.5 because it just works just like that. So now that means you use 128 to the power of 3.5 and then, oops, sorry, 1 over. And you get 4. If you want to just confirm, you can try it again. You can say, oh, 4 to the power of 3.5, what would that be? 128. You're just double checking it and seeing if it really makes sense. Okay. Now, let's have a look at this thing. B log 2 of x equals to log 2 of 8 plus log 2 of 4. I notice this is just a single term with a base of 2, but they both have bases of 2. I could use the rule log 2 of 8 times 4, which becomes log 2 of 32. If log 2 of x equals to log 2 of 32, this means x equals to 32. How good is that? Not bad at all. Not bad at all. Okay. Let's think about this one. I want you to pause the video and have a go at it if you wish. I'm just going to start this right now. If you remember, this is the base, this is the power, this is the answer. 6 to the power of 3 equals to 4x minus 5. Once you lay that out, this becomes so easy. It's very accessible. Do I know what 6 cubed is? No, I do not. But I think it's 216, so I'm just going to assume that. 216 equals to 4x minus 5. So that means 4x equals to 221, x equals to 55.25, something like that. I don't know. Do I care about the answer? No, not yet, not yet. As long as you guys get the procedure, that's all I care about. Okay? It's a thinker. Have a pause at it, have a go. I'm going to go straight into it. Whenever there's multiple terms with logs and the same basis, you think to yourself, how do I make this easier for myself? How could I make this simpler in less number of terms? What I'm going to do is use the rule again, but what are they doing to each other? They're plussing. So what I'm going to do is log 3 of x minus 1 times x plus 1. Okay? And that equals to log 3 of 8. If log 3 of this guy equals to log 3 of this guy, that just means x minus 1 bracket x plus 1 equals to 8. We can just assume that. Like, look, if the answer is the same, we're looking at the same thing. So now we have, sorry, x squared minus 1 equals to 8. So x squared minus 9 equals to 0. That means x equals to plus minus 3. If you want to test it, you can chuck it in there and see if it makes sense. And then you will think about a certain property that you can't have. This was in the do now, the last question in the do now. Oh, no, it was question D, I think. If I have x is negative 3, right? This means I have log 3 of negative 3 minus 1. Sorry, negative 3 minus 1, which is log 3 of negative 4. What does this really mean? This implies 3 to the power of something equals to negative 4. But this is impossible. We cannot have a negative value when you have 3 to the power of a number. So that means x has to equal to just 3 as whatever's inside the log, x minus 1 has to be greater than 0. Always. It has to be always greater than 0. Okay? Why did I just pick x minus 1? Because x plus 1 it's positive for sure. So I don't really have to worry about it. So now x is 3. Okay, we eliminated the negative answer. All right, let's have a look at this. It seems quite similar. Log 10 of x plus 4 over x minus 5. Because it's minus, we do division. That equals to 1. There's a few ways to go about this. You could use complicated log laws and say, oh, 1 must be log base of 10 of 10, and then you equate it. Or you could just BAP it and say, you know what, 10 to the power of 1 equals to all this. So 10 equals to x plus 4 over x minus 5. So now you get 10x minus 50 equals to x plus 4. 9x equals to 54. X equals to 6. How good? Okay, that's about it. Let's have a look at this one. What do we notice? What do we notice about this log? There is no base. Base is not explicitly written down. In this case, we can just kind of assume it's a base of 10, but like that's up to you. Okay, we don't really in this case, it's redundant. We don't have to worry about this right now. So what do we do? Oh, 2 is getting in the way of me directly comparing these two other guys. So what I'm going to do is I'm going to say, you know what? Log x squared, because I can take this guy up to the power, and equals to log 5 plus 4x. Now, what does that mean? X squared equals to 5 plus 4x. That means x squared minus 4x minus 5 equals to 0. What does that mean? X minus 5, x plus 1 equals to 0. Now you get x equals to 5 and negative 1. Are we happy with that? Are we happy with this answer? Well, let's test. Whenever we get a negative answer, I get anxious. Does the negative work for all of these? Oh, if I have log of negative 1, this is like saying 10 to the power of something equals to negative 1, which also doesn't make sense. So we say, you know what, screw you, you're not the answer, you're not what I'm looking for. X equals to 5. Okay, and then that's what we're looking for. Okay, you got to be very careful with these domains. All right. Now, one simple thing that I didn't get a chance to explain to you because I was just worried about your brain because that was just vomiting 50 different things in one lesson. But one easy way for us to easily write log of e, just like it's on your calculators right now, like this guy, okay? Just like this guy. Log of e can just be written as ln x, and you will not lose marks or anything. Don't worry about it, okay? Ln of x equals to 5. Now, once you have this, this is my favorite technique, which is just to replace the annoying thing into something nice. U equals to ln x. So now it becomes u minus 6 over u equals to 5, and you just multiply everything by u. U squared minus 6 equals to 5u. That means u squared minus 5u minus 6 equals to 0. That means u minus 6u plus 1 equals to 0. Then you get u equals to 6 and negative 1. But u is not the answer that we're looking for. ln of 6 equals to 6, and ln of x equals to negative 1. Now what? Oh, sir, there's a negative 1. That's no solution, right? Because this is what you've been doing for the past couple questions. When there's a negative, there's no solution. Well, no. No, you're stupid. Because what we couldn't have a negative was in here. We couldn't have a negative there, but the outside is fine. Because what does it actually mean if I have log e of x equals to 6? This just means e to the power of 6 equals to x. BAP. This is just BAP. I'm changing it to normal logarithmic form. That's the same thing here. E to the power of, oops, sorry, I'm going to write the e first. E to the power of negative 1 equals to x. What is e? I don't know. E is just a number. I'm going to explain to you guys that later. Okay, that's e happens to be just a little number that's like this. It's kind of like pi. Don't worry about it right now. Okay, boom. When you're looking at inequalities, and I'm looking at wealth or income inequality, that's a real world problem right now. I'm talking about mathematical inequalities because they matter more. Okay, when I'm looking at 2 to the x is greater than 9, essentially the idea is when does it become bigger than 9? What value of x does it become greater than 9? If x is 3, then it would be 2 to the power of 3, which is 8. That wouldn't be it. If x is 4, then it would be 2 to the power of 4, which is 16, which is greater than 9. You want to know exactly whereabouts that is. There's two ways to go about it, but I like one in particular. This is one way that I do not really use for any other things except inequality. Okay? Idea is I put log into both of them. So why did you choose base of 2? Because this base is the same as this base. And what I realized, oh, if I take the x out, it becomes x log 2 of 2 is greater than log 2 of 9. cancels out. X is greater than log 2 of 9. And I know you guys were very confused about when I was changing bases. If I have log 2 of 9, actually, you know what? Let me use colors because colors are good ways to distinguish things. If you do this, you can change this into log base of anything you want. You can just make it up. I'm going to say E because that's what's on the calculator. Okay. And I'm going to put the big number on the top, all divided by log E. Again, it has to be the same over and then the small one on 2. So that's what I'm going to check in the calculator. ln 9, ln 2. 3.169. Oh, which is what I expected. Oops, sorry. X is greater than 3.169, but that's what we said, right? It's got to be greater than 3, but less than 4. Because when X is 4, it's already 16. When X is 3, it's 8, which is less than 9. So we knew that. This way is very safe for inequalities, but this is also one of the things that might confuse you a bit more because putting log onto both sides is kind of like a cheat method, which sometimes you're not really understanding how to use BAT properly. A lot of people tend to abuse this rather than using the BAT method because BAT might simplify a lot of things. I would like you guys to have a go at these questions, but you can pause it right now because I'm going to start right into it. Okay. Log, what do you think I'm going to do? Base of 0.4 always. And then 0.4 to the power of x is less than 0.3. Oh, crap. What did I not do? Log into the both sides. Silly Billy. So now what I'm going to do is take the x out. And you get log 0.4 of 0.4 is less than log 0.4, 0.3. And then you get x has to be less than log 0.4, 0.3. Now you can chuck this in the calculator by putting log, so I'm going to rewrite that, 0.3, can be rewritten as log of e or 10. But you know what? I'm going to use 10. Just so you know, you can choose whatever you want. 0.3 all divided by log 10, 0.4. Now I do log 0.3 over log 0.4. Okay, now that you have this, now I can say dot 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 x is less than 1.31396 dot dot dot. All good. I'm going to stop there. Enjoy your work. Have fun. Am I recording still? I am recording still. Good luck.